To meet you today. Today, inshallah, we are going to study a new lesson, which is division of a line segment. Okay, let's see what is the division of line segment here. If we have a line segment AB, like that, okay, a line segment AB is divided by a point C, here please, okay, and this is a division of a line segment, and if we have a line segment AB and we have C point divide AB in two parts, one of them we call it M2, like that, this is M2, and the other part we call it M1, like that. Okay, we have three figures for that. If C be between A and B, so it's internally division. If C outside AB, then it is externally division from right or from left. Okay, OA here means R1, which is the vector R1. We call B R2, the vector R2, and we call OC as R, the vector R, and the vector R will be X and Y, and the question generally is to find the coordinates of C which divides the line segment AB. Okay, so here C divide AB internally because C between A and B. C here divides AB externally and here external also. Okay, so if we have x-axis and y-axis here, this is y-axis and this is x-axis, and this is origin point, of course, here x dash, y and y dash. And also we have x-axis and y-axis of there. Okay, OA we call it R1 all the time, the starting of line segment AB. If we start with A, then A also generally will be R1, and B will be R2, the vector R2, and C, OC is a vector R. Here also the vector R1 is OA, OB is a vector R2, and the vector OC is the vector R. And if we have C here, divide AB internally or externally, here or here, then we say that the vector AC over the vector CB equals what? Equals M2 over M1. And by making cross multiplication here, then we will find that M1 multiplied by AC, the vector AC, equals M2 multiplied by the vector CB. And we know that M1 multiplied by the vector AC, if we would like to find the line segment AC, then we put C minus A as the rules of the vector. AC means C minus A if we would like to find the line segment length, equals also M2 multiplied by CB. CB means B minus C to find the line segment length also, and multiply M1, so it is M1 C, which is R, vector R, minus A, which is vector here R1, all A's here R1, equals M2 multiplied by B. B is R2, the vector R2, and C is R. Okay, and we would like to multiply each of them. M1 R minus M1 R1 equals M2 R2 minus M2 R, and we will collect R in the left hand side. So M1 R plus M2 R equals M1 R1 plus M2 R2. Okay, by taking highest common factor here for R, we will have here M1 from this. We take R as the common factor. We have M1 plus M2 equals M1 R1 here plus M2 R2. Okay, so we have, if we divide by M1 plus M2 in the other side, so we will find that R equals M1 R1 plus M2 R2 over M1 plus M2, and we call this method to divide a line segment the vector method, or the vector form to divide a line segment AB. So if we have C divide a line segment AB internally or externally here, we can find R. R here is C, which is X and Y. Okay, to find the coordinates of C here or here or here, we will applicate this method or this form, which is R equals M1 R1 plus M2 R2 over M1 plus M2. Okay, we will continue division of a line segment here, and we have many examples for you to study. The first example is, if we have, if A, a point here 1 and negative 4, and B 6 and 6, find the coordinates of the point C, which divides the line segment or the vector AB internally by the ratio 3 to 2. So we have the ratio, this ratio called M2 over M1 equals 3 over 2. Okay, and we have a line segment here. We start from A. Okay, so put A here, the left side, and B here. Okay, we start from A to B, and C divides it internally by the ratio 3 to 2. So will be in here, C here. Okay, and here M2, and here M1. M2 will be 3, M1 will be 2. Okay, and we know A 1 and negative 4, B will be 6 and 6, and we know that A equals R1, the vector R1, and B is equal the vector R2, and C is the vector R, which is X and Y, and we want to find this vector X and Y, because he asked me to find the coordinates of the point C, which divides AB internally in the ratio 3 and 2. And by applicating the rule, R equals M1 R1 plus M2 R2 over M1 plus M2, then we can find that. What is M1? M1 here is 2. and R1 here 1 and negative 4. Notice, my dear students, that we use A or R1 with M1 which is far from it, the nearest to the farthest, okay, plus M2 which is 3 multiplied by R2 which 6 and 6 over the sum of M1 plus M2 which is 3 plus 2 equals, here 3 plus 2 equals 5, 2 multiply 1 equals 2 sorry, 2 multiply negative 4 equals negative 8 plus 3 multiply 6 equals 18 and 3 multiply 6 equals 18 also. Okay, we have 5 here. 2 plus 18 equals 20 and negative 8 plus 18 equals 10, and we can divide 20 by 5 equals 4 and 10 divided 5 equals 2. So R, which is C, which is X and Y, the coordinates of it equals 4 and 2. Okay, this is the point C. Here will be 4 and 2. So we have succeeded to find the point of division internally, which is C here. Okay, let's move directly to the example number 2. We have many examples to understand. We have internal division and external division. We have talked now about the division internally by the example which we studied, and now we will solve another example about externally. We have here an example. If A is 2 and negative 3 and B 1 and negative 1, we have 2 points of line segment AB. Find the coordinates of the point C. We can put it at X and Y, the unknown point which divides AB, which divides BA here externally by the ratio 4 and 3. We have here BA and not AB. So I advise you to draw here a line segment starting from B, the left, and A, the right. Okay, then after that we have C, divide them externally here, so we can put C outside A here. Okay, so we have B, which is here is R1. Why it's R1? Because we start from B, we divide BA, not AB. When we start with B, then B will be R1. R1, which is B here, 1 and negative 1. R2, which is A, equals what? Equals 2 and negative 3. And C here, C is R, which is X and Y, which is unknown point. And the division will take this part. We start from B to C and return from C to A. So we have M2 here and M1 here. And M2 here will be 4 and M1 will be 3, but negative. Why it's negative? We deal here with vectors, and vector here M2 starts from B to C, and M2 starts from C returning back to A, so M1 will be negative 3. Okay, and we have here M2 over M1 equals 4 over 3, but externally. Okay, by applying the rule, which is R equals M1 R1 plus M2 R2 over M1 plus M2. Okay, we will find that M1 here, what is M1? It's negative 3 multiplied by R1, which is 1 and the negative 1, plus M2, which is 4, multiplying by R2, which is 2 and negative 3, over M1 plus M2. M1 here negative 3 plus M2 equals 4. So the final answer is equal 1. And here equal 1. Negative 3 multiplied by all of 1 and negative 1. So negative 3 multiplies 1 equal negative 3. Negative 3 multiplied by negative 1 equals 3, plus we multiply 4 by 2 and negative 3. 4 times 2 equals 8, and 4 times negative 3 equals negative 12. Okay, equals negative 3 plus 8 equals 5, and 3 plus negative 12 equals negative 9, all of them over 1. So the final answer will be 5 and negative 9. So R here, which is C, the division point, which is X and Y, equals 5 and negative 9. As he asked me to find the coordinates of the point C which divides AB externally. So we have succeeded to find out the answer. Okay, let's move to another example. We now, my dear students, differentiate between internal division and external division. Okay, we have another example here. If we have example 3, if A equals 3 and negative 1, okay, B equals 5 and 2, and C belongs to straight line AB, so we don't know where is C exactly, such that 2AC equals 3CB. Find the coordinates of C, F. We have two conditions here. The first condition is if the division is internally division. And the condition number 2 or B, the division is externally. So when we draw a straight line here, straight line AB, like that, and we have 2AC here equals 3CB. We can put here as vectors. So AC over CB equals 3 over 2. Okay, why we do this? Why we say that AC over CB equals 3 over 2? I'll explain it to you. Now, concentrate with me. If we have 2AC equals 3CB, okay, we say that AC over CB here equals 3 over 2. Why? Because if we multiply cross multiplication here, 3 times CB equals 3CB, and 2 times AC equals 2AC. So we divide it as this figure. Okay, so we have AC over CB equals 3 over 2. So it's now M2 over M1, and C can be here, and this is M1, M2, sorry, and this is M1. Okay, so here M2 equals 3 and M1 equals 2, and we know A is R1 because he say about the division of line segment AC. R1 here equals 3 and the negative 1, and R2, which is B, will be 5 and 2, and C will be R, which is X and Y, which is we want to find it. Now we will apply the rule because this is internal division. We have here R equals M1 R1 plus M2 R2 plus over M1 plus M2. Here M1 plus M2 equals 3 plus 2. M1 R1, M1 here is 2 times MR1, which is 3 and negative 1, plus M2, which is 3, multiplied by R1, which is R2, sorry, which is 5 and 2. This is 5. 2 times 3 equals 6. 2 times negative 1 equals negative 2, plus 3 times 5 equals 15. 3 times 2 equals 6. Still 5. 6 plus 15 equals 21. Negative 2 plus 6 equals 4. So the final answer will be C, which is X and Y here. The point of division will be 25 over 5 here and 4 over 5. Okay, so the point of division here is C, which is divided internally, and the answer will be X is B is will be 25 over 5 and Y 4 over 5. And we will complete the question now because we have answered only A about division internally, and we have here the straight line like that. This is A, B, and C will divide the line segment AB externally, so C outside AB, and AC will be M2, and CB, we return back, will be M1, and we know that M2 over M1 equals AC over CB, which is 3 over 2. So M2 here is 3 parts, and M1 equals 2 but negative. Why negative? Because we go by AC and return by CB. We go M2 and return by M1, and we deal with vectors, so it's negative. Okay, by applying the rule, we have R equals M1 R1 plus M2 R2 over M1 plus M2, and M1 here equal negative 2 multiplied by R1, which is A, 3 and negative 1, plus M2, which is 3, multiplied by R2, which is B, 5 and 2, okay, over M1, which is negative 2 plus 3, equals, we have here 1, just 1, multiplying that we'll have negative 6 and 2 plus 3 times 5 equals 15 here, 3 times 2 equals 6. Okay, Negative 6 plus 15 will be 9. 2 plus 6 equals 8. Over 1 will be 9 and 8. So when a point C divides the line segment AB externally, the answer will be 9 and 8, or the point C will be which is x and y, 9 and 8. So C here will be 9 and 8 as coordinates. Okay, let's move to another question. We have here a question for you. We have talked about internally and externally, and we studied from a while the division of a line segment in a straight line. And we have another example, which is example number 4. He talks about A. If A equal negative 1 and 4, B will be 5 and negative 2. We have 2 points here, A and B. Find the coordinates of the 2 points C and D. We talk about 2 points will divide the line segment AB, which divide AB into 3 equal parts. So we have here a line segment AB like that, and we would like to divide it into 3 equal parts like that. Say this is D and this is C, and these parts, all of them are equal. And we know that R1 here is A, which is negative 1 and 4. R2, which is B, equals 5 and negative 2. And C here divides. Okay. My dear students, we can continue after a small break. Example here, we have a line segment. We would like to divide it into 3 equal parts and concentrate here to find this. We have a line segment AB here, and we put D and C. This part, which is AD, equals this part, which is DC, and equals this part, of course, which is CB. So if we concentrate about AC as M2, AC here will be M2, and of course we have 2 parts, so it's 2. And CB here is M1, which is 1 part, so it's equal 1. So we can write M2 over M1 equals 2 over 1. It's very easy. And we can applicate the rule, which is R. R here is C, which is X and Y, or we can say X1 and Y1 here, X1 and Y1, because we have D. D will be X2 and Y2 to differentiate between them. So C here, divide the line segment AB with ratio 2 to 1. So M1, where is M1? M1 here is 1 multiplied by R1. Look concentrically, because we have A here far from M1. Okay, so M1 multiplied by R1, which is A, which is negative 1 and 4, plus M2, which is 2, multiplied by B, which is R2, 5 and negative 2, over M1 plus M2, which is 2 plus 1. So we have here 3. 1 times negative 1 and 4, still negative 1 and 4 as it is, plus 2 multiplies 5 equals 10. 2 times negative 2 will be negative 4. So we have 3 here. Negative 1 plus 10 equals 9. 4 plus negative 4 equals 0. And by division, we will find that 9 divided 3 equals 3. And 0 divided 3 equals 0. So the point C is 3 and 0 coordinates. Okay? But we have still need to find the point D. So concentrate with me to find the point D. D here is between A and C. We can write it or draw it like that. We have A, we have C, we have in the middle D. So D in the middle. A will be negative 1 and 4 as it is. C will be what? Will be 3 and 0. Okay, 3 and 0 here is C. So C is 3 and 0. And we have D is a midpoint. Do you remember, my dear students, about the midpoint of a line segment? We have studied in third preparatory that if we have a line segment here, x1 and y1, the coordinates of this point, and this point x2 and y2, and we want to find the midpoint. The midpoint here will be x1 plus x2 over 2 and y1 plus y2 over 2. So we will applicate that here to find the D. D is the midpoint of A and B. So D, which is x2 and y2, as we said, equals what? Equals x1, which is negative 1, plus 3, which is x2 over 2, and this part will be y1, which is 4, plus y2, which is 0 over 2, and then D, which is x2 and y2, equals negative 1 plus 3 equals 2 over 2 and 4 over 2. The final answer will be 1 and 2. So the point D coordinates will be 1 and 2. So we have answered the question completely now, because he asked about A and B, 2 points, and we try to find C and D, which is divide them, the line segment AB, into 3 equal parts. Okay, and we have another example for you. Let's concentrate. We have an example here. Example 5. Example 5 talks about the parallelogram ABCD. We have ABCD is a parallelogram. We can draw a parallelogram like that. Okay. Okay. We have a parallelogram here. It's A, B, C, D. Take it roundly. A, B, C, D. Not A, B, C, D. Some of you make a mistake here. So we go round A, B, C, D to draw parallelogram correctly. And he give me the point A coordinates, which is 5 and 2, and gave me the B coordinates 0 and 3. Also the coordinates of C, negative 2 and negative 1. And ask me to find the coordinates of D. We can say X and Y. Yes. How we find the coordinates of D? In fact, we have 2 methods. The first method is talk about the midpoint of diagonals. We have the diagonals here, AC and BD intersect at the point M, and we know that diagonals of parallelogram bisect each other. Okay, they are bisect each other, and if we succeed to find the point B by division, we can, if we succeed to find the point M by division, we will find the point D. How can we find it? We know that M is the midpoint of BD, but we have D unknown up till now. But we have M is the midpoint of AC, and A and C are known here as R1 and R2. Okay, M and midpoint, as a midpoint, as we said, we can easily find it. Here x1 plus x2, which is 5, and negative 1, which is 4, and we add y2 plus y1 plus y2, 2 plus negative 1 equals 1, here over 2 and here over 2. So the coordinates of M will be 2.5. Okay, let's see it carefully. We have here A 5 and 2, and C negative, sorry, we have C negative 2 and negative 1. Okay, I write it faultly, negative 2 and negative 1 here. So 5 plus negative 2 will be 3, not 4, and 2 plus negative 1 still 1. So here is 3 over 2.5. So M here is 3 and over 2.5 here. Okay, okay, and we have the point D. We have the point D, X and Y. Okay, let M the midpoint of BD. M here is 3 over 2.5 and comes from the midpoint X plus 0 over 2 by applicating the rule of division of, and Y plus 3 over 2, because M is the midpoint of BD. So we add X to 0 over 2, and we add Y plus 3 over 2, and it is equal 3 over 2.5, because we have M here 3 over 2.5 from the other side of diagonal. We have here X over 2, the first one here, equal the first one, equals 3 over 2. So we can deduce that X equals 3. And also Y plus 3 over 2 equals half. So we can deduce that Y plus 3 equals 1. Okay, we have 3, X equals 3 and Y plus 3 equal 1. So Y by transfer 3 to be negative 3, negative 3 plus 1 equals negative 2. So we have X equals 3 and Y equals negative 2. So we have the point D, which is X and Y, equals 3 and negative 2. Okay, this is an easy method for you to find the coordinates of D. But we have another method. I consider it easier for you. We have a method which called vector method. We have here the vector AB and vector DC. Because ABCD is a parallelogram, so the vector AB here, of course, equals the vector DC. We have the same direction and same magnitude. And we know that the vector AB, if we would like to find the line segment AB, we put here the vector B minus vector A equals DC, means C minus D. which is B? B here is 0 and 3 minus A, which is 5 and 2, okay, equals C, which is negative 2 and negative 1, minus D, which is X and Y, okay, and we will complete. 0 minus 5 equal negative 5, 3 minus 2 will be 1, equals negative 2 minus X, and negative 1 minus Y. And we have the first coordinate equal first coordinate, so negative 2 minus X equals negative 5. So we can put negative X here equals negative 5 plus 2. So negative X equals negative 3. So X equals 3. The second part, negative 1 minus Y equals 1, because the second coordinate equals second coordinate in the order pairs. So negative Y equal 1 plus 1. Negative Y equals 2. So Y equals negative 2. And the final answer will be X equals 3 and Y equal negative 2. So the point D, its coordinates will be 3 and negative 2, and we have the same answer. The last answer here, D is 3 and negative 2, okay, and this answer also 3 and negative 2. Okay, let's move to another example. Example number 6. We have an easy example. The example said that prove that the points A, B, and C lie on a straight line. Then find the ratio by which the point C divides AB and the ratio by which the point A divides BC. We will solve it. Solution. We want to prove that A, B, and C are collinear. By using vectors, if we find the vector AB, which is B minus A, which is negative 2 and negative 9, minus A, which is 1 and negative 3, negative 2 minus 1 equal negative 3, and negative 9 minus negative 3 means negative 9 plus 3 equal negative 6. So AB equal negative 6, and we can take negative 3 as a common factor here. Negative 3 divided negative 3 equals 1, and negative 6 divided negative 3 equals 2. This is equation number 1. And we can find the vector AC. The vector AC means C minus A. C is 5 and 5 from here, minus A, which is 1 and negative 3. 5 minus 1 equals 4, and 5 minus negative 3 equals 8. And we can take 4 as a common factor. It will be 1 and 2. Notice that we have here negative 3 and multiplied 1 and 2, and 4 multiplied 1 and 2. If we divide AB over AC, we will take negative 3 multiply 2 and 1 and 2 over 4, 1 and 2 also. By cancelling 1 and 2, the answer will be negative 3 over 4. That means that AB as a vector equal negative 3 over 4 the vector AC. What is the meaning of that? We know that if vector equals k, whatever the k is a real number, multiplied another vector, then AB and AC are parallel, but here we have a common point. So we will deduce that A, B, and C are collinear. Okay, so the method depends on to find a vector AB and the vector AC, or we can say vector AB and the vector BC, and you will find that one vector equal a number or a real number multiplied the other vector. Generally it's or theoretically it will parallel, they will parallel, but we have a point here, a common point A, so they will be on the same straight line or collinear. Now let's complete the question. The question demands here is to find the ratio by which the point C divides AB. So we have AB here and A 1 and negative 3, B equals negative 2 and negative 9. Okay, and we know that we can say that C, okay, divides it as two parts, M2 and M1. Okay, C is X and Y. Here A is R1, B is R2, as we said before, and by applicating the rule that C or R equals M1 R1. What is M1 and M2 here? Here we have studied that, or we deduced that AB over AC equal negative 3 over 4. Okay, so we can say that M2 is 3 and M1 equals 4. 3 and 4, and ignore negative here because it will be give you the answer well. R here equal M1, which is 4, multiply R1, which is negative 1 and negative 3, plus M2 equals 3 multiplied by R2 multiplied M2, which is here B negative 2 and negative 9, over the sum of them 3 plus 4. Here the sum equals 7. 4 times 1 equals 4. 4 times negative 3 equals negative 12, plus 3 times negative 2 equals negative 6. 3 times negative 9 equals 27, negative 27. 4 plus negative 6 here equals negative 2. Negative 12 plus negative 27 here. Okay. Negative 12 plus negative 27 equals 7 plus 2 equals 9, and 2 plus 1 equals 3, so negative 93. Okay, over 7. I think it's something wrong here, because we have A, it's example number 6, yes. We have negative 3 over 4, and we have A equals 1 and negative 3. Okay. Okay. Let's move to again the ratio. He would like to find the ratio here, the ratio which is M1 and M2. So we will draw here A and B and C, M2 here and M1 there. Okay, we have already A, C and B. We have A 1 and the negative 3, B is negative 2 and negative 9, C is 5 and 5. Already we have C, so we don't concern concerned about C, we concern about M1 and M2. So here A is R1 and B is R2 and C is R, and the unknown here is M1 and M2 because he asked us to find the ratio. Okay, so we will applicate the rule M1 R1, which is M1 multiplied 1 and negative 3 plus M2 R2, which is negative 2 and negative 9 over M1 plus M2 equals what? Equals 5 and 5 already. Okay, so here M1 times 1 equals M1 and negative 3 M1 plus M2 times negative 2 equals negative 2 M2 plus negative 5 M2 over M1 plus M2 equals 5 and 5. Okay, so M1 here minus 2 M2 over M1 plus M2 equals 5, and also negative 3 M1 plus negative 5 M2 over M1 plus M2 equals 5, which is this one. Okay, so we will complete that. Here, by making cross multiplication, we will find that M2 you will find that M2 over M1 equal 4 over negative 7. That means that if we draw here the correct drawing, B will be here and A here and C there, and this is AC as M2 here, which is 4, and CB, okay, which is negative 7. So the ratio will be M2 and over M1 equal 4 over negative 7, or M2 over M1 equal 4 over 7 externally. Okay, and also easily we can find out that the ratio of division of a line segment BC by a point A, here is M2, here is M1, and we can find out that M2 over M1 equals 3 over 4. Okay, then we answered the question 1. My dear students, is the final of our finished of our lesson for today. Until we meet again, goodbye and good luck.